In this video, we'll discuss the overall idea for how we're going to want to solve circuits for their Thevenin or Norton equivalent. And there's really kind of three aspects of it. One thing that we're going to do is we have some sort of complicated circuit with the terminals. If we just leave those terminals not connected to anything, and we measure the voltage between those two terminals, and we can do that with node voltage, mesh current, whatever. If we can measure that voltage, we're going to call that the VOC for the open circuit voltage, right? You left the circuit open between the terminals A and B, and it turns out that the open circuit voltage is going to be the same as the V Thevenin that we had in the Thevenin's theorem. On the other hand, if you take your two terminals A and B, and you actually short between them, so you just directly connect them here, and you measure the current going through that part, maybe via mesh current or something like that, then you're going to get something called the ISC, which is the short circuit current, and it turns out that is the exact same as the Norton current that was mentioned in Norton's theorem. On the other hand, if you take your circuit and you turn off all of your independent sources in there, and to measure the resistance between those two terminals, that will give you your R Thevenin. And then it turns out we have a nice relationship that VOC is equal to ISC times R Thevenin. Basically, again, it looks like Ohm's law. It's not actually Ohm's law, but it looks like Ohm's law here. It's actually source transformation. And it's just telling you that if you can measure any two of the three of open circuit voltage, R Thevenin, and the short circuit current, if you can get two of those three, you can use this equation to find the third. And in particular, this idea right here is really great if you have an actual physical circuit in front of you and you have a multimeter, because you can hook up your multimeter to these two terminals, A and B, and if you take the multimeter and you turn it to the voltmeter setting, well, a voltmeter acts as basically an open circuit. It's a really high resistance circuit, and so having it in the voltmeter setting will measure your VOC. If you then take that same meter hooked up in the same fashion and you turn it to the ammeter reading, an ammeter is basically a short circuit, so you're essentially putting a short circuit between terminals, and guess what? The current you read is going to be exactly the ISC. So literally you just plug in your multimeter one time, turn your bar to voltmeter, you get the VOC, turn it to the ammeter, you get the ISC, divide them, you get the R Thevenin, and you're good to go. But that's only if you have a physical circuit you can do it. Otherwise, we're going to see in another video mathematically how we're going to solve for these and get our answer.